Welcome to Creative Mathematics and Coding with CodeWorld. You're at Unit 1, Lesson 6, Part 1, Nesting Expressions. In the last part, you finally put together the pieces and drew some creative pictures using basic geometric shapes, colors, and translation. You might have noticed in the process that you needed to define a lot of variables. In this lesson, we'll look at an alternative way to write your programs that doesn't require as many names. To get there, let's consider an idea called substitution. The code you're looking at here consists of two equations, and you may remember that an equation is a statement that two expressions are equal or have the same value. The second of these equations tells you that the expression base has the same value as the expression solid circle 1 involving a function and its argument. Because these two expressions mean the same thing, it doesn't actually matter whether we choose to write one or the other. So you could take the word base in this first equation and replace it with solid circle 1 without changing the meaning of ball. Once you've done this, you don't need to define base, because the shape you were referring to by base is just written directly inside the definition of ball. This technique can save you from having to define so many different names in your code, but it also makes your expressions just a little more complicated. You might notice that on the right-hand side of this equal sign, we have two functions. The function colored has these two arguments, solid circle 1 and red, but inside one of those arguments is yet another use of a function. So instead of just a frying pan, we have one frying pan inside of another. I guess you could think of it like cooking one of the ingredients before you add it to the larger dish. Placing one function inside of another in this way is called nesting. One key to understanding nesting in your code is being able to match parentheses. Remember that parentheses always come in pairs, an open parenthesis and a closed parenthesis, which often surround the arguments to a function. When you have a pair of parentheses, you can complete the circle that they form, like this. When you've got parentheses inside of other parentheses, though, it might not be obvious exactly how these match up. Suppose you tried to match the first open parenthesis with the first closed parenthesis, like this. That looks good for now, but when we try to match the remaining parentheses, these lines will cross. And crossing lines is no good. One pair of parentheses must live inside or outside the other. They can't overlap like this. So instead, we'll need to match these up in a different way, matching the inside parentheses together and the outside parentheses around that. That sounds simple, right? But let's try a more complicated example. Can you match up the parentheses here? Remember, the strategy is to work from the inside out. So we'll start by looking at parentheses that are facing each other with nothing in between. Here's one, and here's another. Now that we've matched that second pair of parentheses, there are no unmatched parentheses preventing us from matching these as well. And continuing to work from the inside out, we can match the parentheses that contain all of this. Finally, we've got one pair left over at the end. See how that works? Just work from the inside out. This strategy of working from the inside out applies to expressions with functions as well. We'll complete our frying pans in this function, but to make sure we get the right parentheses together, we'll work from the inside out to do it. First, the parentheses associated with circle obviously go together, so let's complete that frying pan first. And let's remember what it means. Circle is a function which takes an input, the number 3, and uses that to produce an output, just a picture with a circle of radius 3 on it. Now that we've grouped this expression circle 3 that describes a picture, we can turn to the parentheses around that, again working from the inside out. These parentheses belong to the translated function, like this. Once again, let's remember what this means. The translated function has 3 inputs. The first is just that circle, and the second two are the numbers 3 and 5. The way to think about this is that the output from the circle function is connected directly to the first input of the translated function, like you see here. It's like we're building a more complicated machine out of simpler parts. We can now look at that entire translated function and its arguments as one expression and complete the function around it. That function is colored, and it looks like this. That corresponds to yet another piece in our machine. The output from the translated function is connected directly to the first input to colored, and then the color blue is provided as a second input. And finally, we'll connect the parentheses for the outermost function, the drawing of function, like this. We can put this all together and write an equation to define that special variable program to have the same value as the complicated expression to the right. Now we've described a program involving a shape and two translations without needing to define any extra variables. There's a trade-off though. This is a lot harder to read and understand, isn't it? It's a balance you'll have to set for yourself. If the variable communicates better, do it that way. If combining everything into one expression is easier, do it this way instead. When you read a complicated expression like this, sometimes you have the question, which parenthesis matches this one? Take this open parenthesis corresponding to the colored function. Can you tell at a glance which of the many closed parentheses matches that open parenthesis? You could work inside out to answer this question just as we did earlier. But if you just want to find this one matching pair, there's another trick you can use. We're going to count parentheses starting from the open parenthesis that we'd like to match. And every time we see an open parenthesis, we'll count up by 1. So this parenthesis is 1, then 2, then 3. Every time we see a closed parenthesis, we'll count down by 1. So we're back to 2, back to 1, and then down to 0. When you reach 0, that's the parenthesis that matches the one you started with. 0 means match. So we can connect those parentheses to recognize the colored function and its arguments. Okay, now it's your turn. Try writing code that describes a program with a picture of your choice, but do it without defining any other variables, except that special variable program that you have to define. You may not want to make it too complicated, but try to get at least a couple of transformations, maybe an and sign in there. Give it a shot. I'll see you next time.